So we're going to talk about doing the algebra to represent these transformations, whether it's a translation, a reflection, or rotation. When we did translation, we talked about the algebra. Literally, if you're moving left or right, that's along the x-axis. So you're just adding or subtracting. So that one's pretty simple. And here's our translation one we did. If we go right, all we're doing is adding to the x-coordinate. If we go left, we're subtracting from the x-coordinate. If we go up, we're adding to the y-coordinate. If we go down, we're subtracting from the y-coordinate. Translations are probably the easiest to represent of all and the most forward, except for dilations, which we'll get next week. Dilations are way easier even than that. So let's talk about reflections. Reflections aren't hard when you think about it. When I reflect over the x-axis, so I've got an x-axis is my horizontal axis, right? When I reflect over it, what coordinate is changing?
The X.
Y.
The x.
Oh.
And what's happening to it? What's
flipping?
Yeah, it's literally going to the opposite sign. So to do across the x-axis, I'm changing the y-coordinate by negative. I don't know if I said it the opposite way there. So the x-axis, the x-coordinate stays the same, but the y-coordinate changes, and it literally becomes the negative. Can you guys focus?
I thought they were ladies.
Across the y-axis. That's my vertical axis. The y-coordinate stays the same, but the x-axis gets flipped. So think about that. If it's across the x-axis, I leave x alone. If it's across the y-axis, I leave y alone. But the other coordinate becomes the opposite. So pretty easy to see a reflection. The last one is a little more unique. And we'll take some memory on your part. So to go rotations, you'll notice that I only list 3 rotations. 90 degrees clockwise, 90 degrees counterclockwise, and 180 degrees. Why don't I list 270 degrees?
Because it's just 90 degrees the other way.
It's just 90 degrees the other way. That's an excellent way to put it.
Same thing.
Trayson's about ready to teach his class because he's got it.
I'm so smart.
So now think about this. When you go clockwise, you're literally multiplying the x-coordinate by 1 and flipping the coordinates. So it becomes y comma negative x. So if I started out with a coordinate, let's say my original coordinate was 6 comma 6. And I rotated it 90 degrees clockwise. Actually, let me put something different there.
Yeah.
6 comma 5, how's that? I just thought about that. So if I rotate it clockwise, my y stays the same, but it becomes the first coordinate. It swaps in. So it becomes 5, and my x-coordinate becomes a negative. So when I flip those, 5 comma 6 becomes, or 6 comma 5 becomes 5 comma negative 6. Does that make sense? Did you write that down?
Yes, I did.
So let's think about the other way. If I go counterclockwise, I'm doing the exact opposite, meaning I'm still flipping my coordinates, but the negative goes with the y. So clockwise, the negative hangs with the x. Counterclockwise, it hangs with the y.
I didn't do it. I promise.
Okay, so let's think about it. Let's think about the same coordinates I had before. I had 6 comma 5, and I want to go 90 degrees counterclockwise. I'm switching them up so that 5 is first, but now it's a negative 5. And then x is second, but now it's 6. So my new coordinates for my new x is negative 5, my new y is 6. 180 degrees. Both things apply. But we don't have to flop them. We just multiply both of them by negative 1. So before I had 6 comma 5, my new coordinate going 180 degrees is negative 6, comma, negative 5. Does that make sense? That one is a little less intuitive than all the rest. But once you do it a couple times, it'll make sense.
Intuitive. That's a big word.
It is a big word. We're going to use it today. So let's look at, actually let me adjust this down just a teeny bit. Let's look at a couple of problems. So the first one, we're not even having graphs now. We're just finding new coordinates. So this one says a rectangle has vertices of 0, 2, 0, negative 2, 0, 3, and 3, negative 2, and lastly 3, comma 3. What are the coordinates of the vertices of the image after a translation? Translation means I'm moving it left and right, or up and down, right? XY is x minus 6, y minus 3. Describe the translation. Well, let's start with describing the translation. X minus 6, which way are we going? Which way are we going, Elena? X minus 6. If we got x and we're moving in a negative direction, which way are we going? From yours, it's this way. Are we going positive or negative? So this one says, and it pretty much says it right there, right? Left, 6. Are we, with y minus 3, are we going up or down, Bryson?
Down.
Down. And how many?
5.
Down 3. It says right there. So let's make our new coordinates. And probably the easiest way to do this, so that you get it right, is I'm going to put my 0, comma, negative 2. That's my first coordinate, right? And I'm going to put a little arrow to show I'm making the translation. Focus. So I'm going to do a little arrow to show I'm making my translation. So,
Ladies, shut up.
really. So 0, and it's x minus 6. So what's 0 minus 6?
Negative 6.
Negative 6. And it says y minus 3. What's negative 2 minus 3? Negative 5. I'll do my second coordinate, which is 0, comma 3. Do my little arrow there. We already know, we did it before, right? What's 0 minus 6?
Negative 6.
And 3 minus 3.
0.
Okay, slow down, Bryson. You're doing well. All right, Peyton.
What?
My next coordinate is 3, comma, negative 2. And I'm going to translate it. How would I translate 3, negative 2 using x minus 6 and y minus 3? What are my new coordinates? Let her get it. Okay. Look at that first coordinate. That's 3, right? Go up to your, what are you using for your translation, which is x minus 6 and y minus 3. What are you doing to the x coordinate? What are we doing to the x coordinate? Look what it says up there. What does it say at the beginning there?
Right there under the second. Right,
What does it say we're doing right here to it?
right there.
Oh.
What are we doing to it?
To the X.
Subtracting how much? 6. So what's 3 minus 6?
3.
Negative.
Negative 3.
Negative 3. And now what are we doing to the y coordinate?
Subtracting.
How much?
3.
So our y coordinate is negative 2. What's negative 2 minus 3?
Negative 1.
Negative 2 minus 3. Two negatives, keep the sign, and add them together.
Wait. 3 and 2.
Mm-hmm.
It's negative.
5.
Negative 5. Very good. All right, Joshua, you get to pick up the last one here. So our coordinates are 3, comma 3. What's our translated coordinates? Yep. What's 3 minus 6? And what's our y coordinate?
0.
Very good.
Bryson, shut your mouth.
Bryson, unless you're part of the conversation and it's about what we're talking about, do not talk anymore.
He's saying the answers.
I know. Okay, let's look at number 2. It says triangle ABC has vertices of A is -2, 6, B is 0, 5, and C is 3, -1. What's a vertice?
The vertice is a vertical that you can see.
What is a vertice?
I honestly.
We're using it a lot. A vertice is where two lines intersect and make a point.
Vertex also?
It's called a vertex. But vertices is the plural.
I think you said vertex.
Yep, but this is the plural, and that's what I knew that there was. So find the vertices of the triangle ABC after reflection across the x-axis. So they don't give us the formula here, do they? So let's make the formula. So we start with x comma y, and this is how we write our algebra formulas. So x comma y, and we put a little arrow indicating go right. Now, if we're reflecting across the x-axis, which one stays the same?
X.
X stays the same, right? Reflect across. So x stays the same. What happens to the y?
It,
Turns into a negative.
It turns into a negative. So now we've got our solution, right? So let's go to our 3 points. So A is -2, 6. Elena, if we apply our x comma -y to A, what are the new coordinates? Does x change? So x stays the same. Does y change? What does it become? A negative. So if it's 6, what's the new y? -6. Okay, let's do B. Jason, you've got B and it's 0 and 5. 0 and -5. Very good. Thank you. And lastly, C, Trayson. Okay.
Can I do it?
No. I'll let you do some of the next one.
I know it.
You will. This is just practice. All right, Trayson, did you catch up? Okay. You're applying the equation x comma -y to it.
Okay. So it would be 3,
Mm-hmm.
comma, negative.
It's already -1, right?
So it'd be 1.
It'd be 1. Very good. So we didn't even have to graph this to do the work, right?
Nope.
So those of you who hate graphing, this is like your line of business.
I get it.
All right. Let's do number 3. It's the last one. It's a triangle that has vertices at J, -2, -4, K, 1, 5, and L, 2, 2. What are the coordinates of vertices of the image of the triangle if it's rotated 90 degrees counterclockwise?
Before that, I have a question. Do you have a Band-Aid?
Yes, but let's finish this first. So we don't have a formula, right? So let's start with our formula, x comma y converted to, what happens when I rotate 90 degrees counterclockwise? We already know the 90s are going to flip the x and the y, right? So we already know that it's going to be y comma x, right? Which one becomes negative?
The Y.
The y.
Oh, what?
If we go counterclockwise, the y becomes negative.
I need that totally.
Okay?
I want to see if you on it.
So
You're just testing me?
I just
All right, so we're going to
Can't even see test.
when we convert, our new coordinates will be -y comma x. So let's start with J. J is -2 comma -4. Jason, have I called you at all yet?
Yeah.
Okay. Peyton,
What?
if our coordinates for J are -2, -4, what are our new coordinates for J?
Can I catch up on that?
Uh-huh. Follow our rule.
Wouldn't it be positive 2?
Well, remember, we're flipping, right?
Uh-huh.
So the first one would be negative x, or negative y, sorry. So which one of these two, negative 2 and comma negative 4, which is the y coordinate?
4?
The 4. And we,
It'd be positive 4.
comma,
Comma,
did we do anything to the x at all?
no,
So,
negative 2.
negative 2. Very good. Travis,
Yes.
we've got k and it's 1 comma 5. Using our formula here, what's our new k?
Negative 5, 1.
Negative 5 comma 1. Very good. And last one here, Joshua. L is 2 comma 2. What's our new coordinate?
Negative 2.
Don't turn it off.
Very good.
I'm just gonna flip it.
Again, these are a little more left. The rotation for me is the one that's hardest for me to picture. The other ones make sense. If you're reflecting, you're just moving it left and right. But this way, you could do, think about this. If you're a computer programmer, and you've got, let's say you've got a triangle of death, and it spins across the screen. So as it's spinning, you can program it to translate, if your character's on the left, and that triangle of death is coming from the right, you can program it to translate from right to left, and at the same time, to rotate on itself. That way it looks like a spinning triangle of death.
Oh, this is wait.
Does that make sense? That's kind of how it's used. That's how computers do it. And you don't actually graph or draw the pixels. You program it into the program and it draws the pixels for you spinning.
Wait, this is
Hmm?
algebra? Algebra's easy then.
All right, any questions?
Program.